and all our solid rocket motors, their names are dedicated to Dr. APJ Abdul Kalam, our very own missile man, and all our cryogenic engines. We have dedicated the names to Dr. Satish Dhawan, which we are like the center we have also, Satish Dhawan Space Center, dedicated to him. And then we have our hypergolic engines, Raman. And then we have dedicated that name to Nobel laureate Dr. C.V. Raman, and our mission computer after the renowned mathematician Srinivas Ramanujam.
So yeah, I think we're gonna keep up this idea of naming our hardwares after scientists.
Until we run out of scientists.
Yeah, so I think
Not the hardware.
we need the young budding viewers who've joined us in the launch gallery to become scientists themselves and famed scientists who take India to great heights, so that we may have names.
Yes, right now, maybe. Coming to one more interesting fact, I think a lot of people, they don't know this. Like, if you look at a launch vehicle, it seems pretty rigid at first. But the interesting fact is when the entire rocket, when in flight, it experiences combined effect of aerodynamic loads, engine thrust, wind gust, and due to different steering maneuvers, the teams or the designers deliberately give some flexure, or like they make rockets slightly less rigid so that it can actually bend along its length throughout the flight. This is intentional, that designing an absolutely rigid rocket would make it significantly heavier and less efficient. And it also creates a complex engineering challenge. As the structure bends, the onboard sensors can detect these motions, so the guidance and control system must distinguish the rocket's actual attitude and structural flexing to avoid unnecessary control corrections. And engineers carefully predict these bending modes and their natural frequencies through the structural dynamics and aeroelastic analysis, ensuring the vehicle remains stable even as it flexes its way through one of the most demanding phases. And this flexure could go up close to 10 centimeters, I think. Yeah, close to 10 centimeters. That's pretty huge.
That's right, Akhil. Something for the kids who might be, looking at this live stream. So rockets don't just fly, they keep falling around Earth. It might be difficult to imagine this, but people often imagine astronauts escaping Earth's gravity. The truth is, gravity never lets go. Even the International Space Station is constantly falling towards the Earth, but it's moving sideways at so high speed that it keeps missing the ground. And that's what we call as orbit.
Yeah, that's wonderfully put.
Orbit is a state of perpetual freefall.
Yeah, that's right. And you spoke about how astronauts on the International Space Stations are also constantly falling towards Earth. And with us today in the Mission Control Center is our very own astronaut, Shubhanshu Shukla. And he's been following Skyroot's journey from a very close distance. He's part of our family as well. And he's here to cheer us on. So we thank him for his presence.
One more interesting fact for our viewers, that rockets get lighter every second. Unlike an airplane, a rocket becomes lighter every second because it continuously burns and throws away propellant. Because in aircrafts we have air-breathing engines, so the oxidizer itself is the air that the turbofan sucks in. But when you have a rocket, you cannot have. Yeah. So when we are dealing with rockets, there is no air outside air can enter and can be utilized for propulsion. So we have to carry our own bottles of oxidizers and fuel. And once the rocket is ignited and it's on its way through the entire flight, the propellant is expelled, and when the stage gets burned out, it's also thrown away or jettisoned. So that is why rocket keeps accelerating, because there is less and less mass to push.
That's right, Akhil. A rocket may weigh hundreds of tons on the launch pad. Consider our Vikram-1, it weighs around 45,000 kgs on the launch pad, but nearly 90% of that weight is just propellant.
That's really amazing. That structural mass is so less. I mean,
The views on your screen are from the launch gallery at Sriharikota, and we have thousands of students who've joined us from all over the nation, and they're eagerly waiting the launch of India's first privately built orbital launch vehicle, Vikram-1. And of course, like I mentioned earlier, it's a test flight, and we'll be doing a few of these before we move into routine commercial operations. We are in a state of hold for now. For the viewers who just joined us, we have successfully initiated the automatic launch sequence at T-minus 11 minutes, and a lot of the key events that went into this have been executed. We have a hold right now at T-minus 5 minutes, and just to recap, we've had the switchover to internal power, wherein the vehicle is now powering itself. All of the null checks on our actuators have been completed. So essentially, the vehicle's steering systems are in great health. And we're at a planned hold. One quick look at the rocket as well, standing on the launch pad. All right, we are getting updates from the mission control teams. The hold that you observe on your screens was due to a hold raised by the navigation team.
Vehicle directed to launch control. Please do the needful pre-exercises to reinitiate ALS and confirm your readiness.
And we've gotten confirmation that we will be starting ALS shortly. So please stay tuned. So we had a planned hold, and we've just heard from the mission teams below that we are ready to restart the automatic launch sequence shortly. And just to recap once again, Vikram-1 is on the launch pad. It's ready and eagerly awaiting its first test flight. We've had the initiation of the automatic launch sequence, and through that we've completed the internal power switchover, which means the vehicle is now powering itself using its own batteries. We've also had the null checks been completed, and we're now waiting for the next window to come about for the ALS to restart.
so now that we know that the ALS is on hold and soon we'll be back with the new time and the restart of ALS, let's talk about the entire journey of Vikram-1, the mission sequence. Now we know that first 100 seconds of the flight, the stage 1 will power the rocket to the denser layers of the atmosphere, and exactly at an altitude of 53 kilometers at 103 seconds, the stage 1 burnout will happen and the stage separation will initiate. And after that, the stage 2 will ignite and it will power the rocket through the thinner layers of the atmosphere while keeping the same level of acceleration. That is the point. And later on in the stage 2, during the stage 2 burn duration, later half, you have the payload fairing and it separates, and this is the first time when the payload or the satellite is exposed to the atmosphere or to the space, the higher layers of atmosphere, which is exactly nearly close to space. Having protected the satellite throughout the ascent, that the fairing's job is done.
Yeah, that's right, Akhil. And you mentioned that the PLF or the payload fairing is the portion that essentially protects the satellite from the difficulties of the environment that the rocket goes through. The question then becomes, how do we separate all our stages, right? So we use something which is very unique, and we're very proud of that. In-house to Skyroot, we have the separation teams which have developed a pneumatic ultra-low shock mechanism. And the whole goal of this mechanism is it relays very little shock to the payload itself. So the payloads usually carry very sensitive electronics and instruments. So if you have a shock event come about, it may damage some of the sensitive instruments. So that's why we specifically made it a point to develop this pneumatic ultra-low shock separation mechanism.
Like for the knowledge of our viewers, I would also like to reiterate, most typical rockets, they use pyrocords, which use explosive charge to shear out the bolts and separate or jettison the entire stage, which could be catastrophic for some sensitive payloads. That is very costly and could be like you might lose some data from the satellite and affect its workability.
Control here, go ahead.
Definitely.
Still external hold mode is coming.
Right.
Noted.
Now, even after the payload fairing has separated, the job isn't done yet, right? The climb is still going on. Stage 3 steps in and it generates quite a large amount of thrust to essentially power the vehicle into orbit. It keeps pushing it to near orbital velocities, and then comes something different. Like we talked about earlier, we have the orbital adjustment module that kicks in, and this is the stage that I got to work on very closely. Like I mentioned earlier, it was a team of very ingenious, multidisciplinary members. We had teams from systems, propulsion, dynamics, quality, safety, reliability, CFD, design. I mean, you cannot count these fields on the fingers of your hand, and they all had to work in unison to build this stage. And then once it starts working, it will precisely place all of these satellites into its intended orbit. And you might feel like all of this is happening. There's so many things happening, right? But it's just 16 minutes. That's all it takes.
It's so fast, but it seems really long. Like it took us like 1 hour from the entire bus stand to reach Sriharikota. But as Suyash pointed out, so it's such a, we can say the entire rocket engineering, the complexity, looking at the complexity of it, it's like an entire opera house. You have to be like a soprano. You have to be so perfect. Every system, every individual and every component should be in tune to engage all the systems at the right moment so that we can have even a small ignition. And now we have a Vikram-1, which has close to 1,000 subsystems, and almost 2/3 of it will be utilized just even at liftoff. That's really fascinating.
So we've gotten confirmation, and you might see it on your screen shortly as well. The countdown has restarted. We are resetting to T-minus 20 minutes. And we are at T-minus 19 minutes for the information of all our viewers.
Other ground stations about the new T0. Please confirm on
Control timing in external hold mode.
CNC copied, new PGM files shared.
Roger.
Timing to control timing in external hold mode.
Roger.
Skyroot LCC to all, S2 and S3 HMS is event number 97 completed.
Roger. Control to LCC, MCC and RSO. Please note timing confirmed, external hold mode.
Skyroot LCC to all station. New T0 is 12:05 30 seconds.
All right, we are hearing from the mission control that the new T0 time or the liftoff time for Mission Aagaman is reset to 12:05 p.m. So stay tuned, we'll be with you and we'll give you some more space trivia. We have a lot of those, and we'll also take you through the journey of the rocket as well. Many of the times one of the questions that comes is why space? It's so hard. Getting to space is hard enough. Getting to space on the first try is even
All
harder.
stations do not
So if it's so hard,
authorized. The
why
launch
do
of
it at all?
Vikram-1 Mission Aagaman.
What does it hold of such huge importance that we want to strive for making to the stars?
I mean, if you think about it, all the activities that happen on Earth, they are connected in some or the other way to space. Space has quietly become a part of our daily life. Every weather forecast, every map that guides us home, every digital payment and long distance call leans on us. It all leans on a satellite somewhere overhead.
And I mean, it's like the human curiosity that takes you really farther. And like humans, we actually like complex things, and we just it's not just enough to stay on one planet. And so that's why the man decided to take a decision to set off to some higher horizons. And it is still, after 80-90 years, the complexity still remains so high in space travel.
Yeah. And one question that comes about is, how do you make all of that happen?
The new launch time
So-
is 12:05, 30 seconds.
Right, we've just gotten call out and confirmation that the new T0 is 12:05 p.m. Just as a reiteration to all our viewers. So we were talking about what it takes to make all of these happen, and of course we would like to thank ISRO for all their support. From opening the doors to the Satish Dhawan Space Center, the historic first launch pad, issuing us guidance and helping us with all the nitty-gritty details. They've worked with us day and night on this. They've treated this vehicle as though it were their own, and they're so committed to making sure that Mission Aagaman reaches its intended orbit that they've essentially become a part and parcel of the Skyroot family.
They treat the vehicle as their own, as you correctly said, Suyash. Like, they have been involved with us throughout the entire campaign, helped us, and along with ISRO, we would also like to take a pause to thank InSpace, and they have acted as a bridge between the government organization, facilitating all the review meetings, everything, and allowing us access to SHAR, all the policies, all the reforms. So thank you InSpace for all the efforts, and thank you for rooting for Skyroot.
Yeah, one interesting thing, and this is a personal experience as well. We did Mission Prarambh in November 2022, and believe it or not, the headquarters of InSpace were inaugurated in June 2022.
Just 6 months from our first launch.
So you might have to imagine that it's just 6 months, and they've had to imagine and they have to write and draft all the policies that are required. They have to make sure that they know how the mission is going to be, regulated. What do we need to do to essentially handhold the space sector, the private space sector?
It was very seamless, indeed very seamless, the way they took all of it.
Yeah, very true. It definitely is not an easy job, and they've excelled at it. Same goes with ISRO. We've had, cases where they've been chasing after us.
I remember those days.
Yeah, and it's quite empowering to know that the government is playing such a huge role in helping make this happen. We talk about Atmanirbhar Bharat, we talk about Viksit Bharat 2047, and all of these technologies, what the private sector is trying to build today, is essentially contributing to that goal. If we want to be the world leaders, we need to start now.
Exactly, Suyash. Like, I was fortunate enough to visit the LPSC test facility when I was with the Raman-1 test campaign. It was a very great experience. I mean, and the coordination with ISRO teams and the way they facilitated the entire test campaign and the data analysis and post-test, the data came like really fast and like they were after us and they were very patient with us. So yeah, that was a really great experience for the young engineer like me.
Yeah, and that sort of reminds me to the stage test that we did just a couple of months ago. I think nearly 9 months ago.
Yeah, around I think October.
Yeah, October I think. And so that was the test of the orbital adjustment module. It was a all-inclusive test. We had the entire stage. We had all the engines, the thrusters. We had the avionics. We had something quite interesting and melodic as well. We played Sare Jahan Se Acha using the Raman Mini thrusters on the stage, which was something very unique, very captivating to the young minds. Many people did not think that you could play music out of the screeching sounds of 50 Newton Raman Mini thrusters.
Again, an opera, I told you, right?
Yeah, definitely.
Just give me a go. When to say. Just give me a go when to say. अभी तो हम pause है ना.
T minus 11 minutes.
Automated launch sequence initiated.
Roger.
All right, we're at T minus 11 minutes again. T minus 30, 10:30, sorry. And the automatic launch sequence has begun. We are in the pre-checks phase at the moment, where all the teams are essentially checking the health of the vehicle once again, making sure that all systems are operational and go for launch.
Before that, we had one confirmation that all the ground stations supporting today's mission, they have completed their readiness checks. As the vehicle travels downrange, telemetry will seamlessly transition between multiple ground stations, from Shah to Port Blair, then Bogor in Indonesia, and then finally Yatharaga in Australia. This network ensures continuous communication with the launch vehicle, with all mission data relayed back to mission control in real time.
That's right. And just to recap to all our viewers, some of the callouts that have happened till now. We first had the acquisition of day of launch winds, which is we acquire using a Doppler weather radar the winds prevalent. And as Akhil mentioned earlier, it's slightly a cloudy day today for launch, but come rain or sunshine, we are always ready to launch.
Rain can't stop us, I think.
Yeah. And the next thing that we managed to do is, of course, the guidance teams have completed the static navigation profile as well as the gyro compassing of the LINS package. So this is kind of the sensor which tells the attitude of the vehicle, essentially tells you how you're oriented with respect to Earth. And it's something very important that the vehicle has to do. It needs to know where north is and where the direction of gravity is. Post that, like Vaidehi just confirmed, we've had all the ground stations. We have 4 ground stations supporting us today. Shar, which is where we are coming to you live from, and then we have Port Blair, following which we have Bogor in Indonesia, and finally the Yatharga ground station in Australia. So all of these ground stations essentially capture telemetry, which is the data from the vehicle,
minus 8 minutes.
and relay it instantaneously to us.
Yeah, Suyash, you were mentioning about how we also see the wind profiles. The wind profiles are also checked. Just a while back they were checked. And as I can see on the MCC, this wind profile or this data of the winds is also going to be uploaded into the mission computer in the sequence that is coming up. And also, one of the key milestones which have been completed is the transition from external ground power to the rocket's onboard batteries. The vehicle has relied on ground support systems till now, but from this point forward, every stage must successfully power itself. So engineers, I believe, are watching the battery performances and electric health right now to ensure that the transition is smooth and every system is remaining stable as of now.
And for this sequence also, we have completed all the null checks for all the stage nozzles, and the FNCs are working as fine as possible. And we are also happy that Dr. Jitendra Singh, Honorable Minister of Space, is joining us live on video call, and he's rooting for Team Skyroot.
We are at T-minus 6 minutes and counting. For the viewers who've just joined us recently, on your screens right now is the Skyroot Launch Control Center situated at SHAR. We have many engineers looking at the vitals of the vehicle. This includes different teams, starting from avionics, guidance, navigation, control, liquid propulsion, solid propulsion, safety, reliability, quality, and of course our IT teams as well. One of the things that has also been completed just now is the uploading of the mission computer init files. And that's a funny name of sorts, but it essentially means initialization files. These are essentially files that contain all the requisite parameters to tell the vehicle what it needs to do in the early ascent of flight. It adjusts for the day of launch wind profiles that we talked about. It also has the gyro compassing details within it.
And now we have confirmation that mission computer mode has been successfully changed to flight mode, and we are really jubilant, and everybody is really happy that this stage has been successfully transitioned, and now we'll move towards the next check, that is HMSA disarming.
As we enter the final few minutes of countdown, another key safety milestone is underway. The head mount safe arm mechanism will be activated in a while, and till now it was ensured that the ignition chain has remained safely isolated.
That's right, Vedi. For the viewers who are very curious for this, the head mount safe arm mechanism, which we refer to as HMST, is a safety device which is well mounted at the head of our solid rocket motors. And the whole job of this device is to safely isolate the pyrotechnics from the rest of the solid grain. And the reason why we do that is for safety. To prevent any accidental ignition from, let's say, lightning strikes. We do have a cloudy day today, and of course we have lightning suppression systems. We have 4 lightning towers on the first launch pad, but there can also be some form of electrical runaway. There can also be static discharge. So to safeguard all these devices from electrical discharges, we have a mechanical separation between the pyro devices and the solid rocket motor.
Right, so yes. So till now, the ignition system, it was in a protective, non-firing state, but now it's going to move on to a state wherein once the mission computer gives the ignite command, it can initiate a pyrotechnic chain of events.
That's right. And we're at T minus 3 minutes, and we have confirmation that the stage 1 head mount safe arm mechanism, or the stage 1 HMSA, has been successfully armed.
This basically means that our motor is now ready to ignite.
That's really great to hear. Along with this HMSA safety mechanism, we have one more layer of safety which we call the FTS or the CDS, Command District System, or the Flight Termination System. This is utilized when if the vehicle during its flight mode tries to or like deviates from its intended flight trajectory, then the range safety officer can take a call to destruct the vehicle to safeguard the resources around it.
T minus 2 minutes.
That's right. As is with the case with any launch vehicle, we always prioritize safety, and with that in mind, we have all of these systems set up on the vehicle.
You can talk like normal.
We are now entering to condition the liquid stages on Vikram-1. So the orbital adjustment module is now conditioning itself and preparing for liftoff. So we are nearly at T minus 1 minute,
All stations.
and
Stand by for the
we
timer.
will leave you
T
with
minus
the
1 minute.
views of Vikram-1 and join you shortly at
Minus
liftoff.
55 seconds. Minus 50 seconds. Minus 45 seconds. Minus 40 seconds. Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds. Minus 20 seconds.
Minus 20 seconds is the call out now.
Minus 20 seconds.
Minus 15 seconds.
15.
10, 9,
9,
8,
8,
7, 6, 5, 4, 3, 2, 1, 0.
And we have liftoff of Vikram-1, India's first private orbital launch vehicle. And we have great views coming from the tracking cameras. And isn't this quite something?
विक्रम-1 ने अपनी उड़ान भरी, प्रथम चरण का प्रज्वलन प्रारंभ किया। विक्रम-1 ने प्रक्षेपण पथ को लांघकर आकाश को भेदने का निर्णय ले लिया है, एक ब्रह्मास्त्र की तरह।
That's very true, Suyash and Akhil. I am awestruck at the sheer power that stage 1 is producing. With this, we have two of our major prime mission objectives completed, which was successful ignition and safe tower clearance.
That's right, and we are coming up on max Q now, which is the period of maximum aerodynamic pressure, where the vehicle faces its largest aerodynamic loads as it flies through this zone at Mach 1.5 at an altitude of nearly 9 kilometers.
विक्रम-1 ने सफलतापूर्वक मैक्स क्षेत्र पार कर लिया है और
Plus 1 minute. Sharp 2 minute.
दल काफी उत्साहित है इस समय, और विक्रम-1 प्रथम चरण के आगे बढ़ रहा है और हमें श्रीहरिकोटा व पोर्ट ब्लेयर पृथ्वी स्टेशन से मजबूत दूर संकेत मिल रहे हैं, जो बहुत ही अच्छी खबर है।
That's right, we are at a downrange distance of 22 kilometers with an altitude of 34 kilometers.
Oh my god, we got this.
And on your screens right now are excellent onboard camera views from the vehicle.
And we can also see quite nominal chamber pressure values on the MCC screen.
Inside camera.
The vehicle is currently at an altitude of 50 kilometers.
और यहाँ पे प्रथम चरण का प्रतिकरण हो चुका है और द्वितीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
This is quite a major achievement for the nation with the vehicle successfully separating stage 1 and the ignition of stage 2 as well.
Stage 1 is solid booster.
द्वितीय चरण अपना सफलतापूर्वक कार्य पूरा कर रहा है और प्रथम चरण का दहन अथवा प्रतिकरण समाप्त हो चुका है.
The vehicle is at an altitude of 89 kilometers, traveling at 2.6 kilometers per second. Of course, our target velocity for today is 7.6.
S2 performance normal.
We've just heard call out that the S2 performance or the stage 2 performance is nominal.
ये एक ऐतिहासिक क्षण है पूरे भारत और निजी अंतरिक्ष यात्रा का.
This vehicle has crossed 100 kilometers of altitude, which is the notion of edge of space, and we have reached space, guys.
Congratulations, Vikram-1 is in space.
हमारा यान अंतरिक्ष तक पहुंच चुका है.
And we've had callouts of separation of the payload fairing. We have successful payload fairing separation.
These guys are like they
It's nearly at an altitude of 120 kilometers, and the protective fairing is no longer required and has been cleanly separated from the launch vehicle.
और यहाँ पे द्वितीय चरण का भी प्रतिकरण संपन्न हो चुका है और तृतीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
That's right, Akhil. We've had successful ignition of stage 3. The vehicle is currently at 157 kilometers above the Earth's surface. It is 355 kilometers downrange, traveling at nearly 4 kilometers per second. Now, the telemetry will switch over from Shar to Port Blair and further to Bogor.
अब यान अपनी अंतरिक्ष यात्रा पर निकल चुका है. तृतीय चरण का प्रज्वलन चालू है और उसकी प्रतिक्रिया नियमित रूप से चल रही है.
And as you can see on your screens, we have near exact following of the intended trajectory. The two dotted with the two lines on your screen essentially indicate the current performance of the vehicle, and it closely matches with prediction. This is on your screen on board from stage 3. What you see is the rocket plume and the nozzle and Earth, our home.
What a beautiful view. क्या सुंदर दृश्य है हमारी पृथ्वी का.
S3 performance normal.
और तृतीय चरण का परफॉर्मेंस अब नॉर्मल है, या कि सामान्य रूप से तृतीय चरण का संचालन प्रारंभ हो चुका है और चल रहा है.
That's right. We've had call out that the stage 3 performance is nominal.
Plus 5 minutes.
So stage 3 has a propellant loading of 2.5 tons, and we've had burnout of the stage 3 motor as planned at T plus 5 minutes. Yes, we've gotten confirmation that S3 has burnt out, and now we're entering a planned coast period. Something that lasts for 140 seconds, in which it's called as combined
Coasting is normal.
Right, so we've got call out that the combined coast is nominal. This will last for roughly 140 seconds, where stage 3 is not producing thrust, but it's connected to the vehicle and it's going to coast as a single body. All of this is done to manage the altitude of the vehicle and also control where the stage will re-enter the Earth's atmosphere before splashing in international waters in a safe and planned manner. And jubilant views from the launch control center, where the teams are extremely elated and excited.
और मिशन नियंत्रण केंद्र और लॉन्च नियंत्रण केंद्र से आपको दृश्य दिखाई दे रहे हैं. सभी यान परीक्षण दल अत्यंत ही प्रसन्न है और यहाँ पर जो प्रसंग है वो एक उत्सव का प्रसंग बन चुका है. एक ऐतिहासिक क्षण भारत के निजी अंतरिक्ष उड़ान का. विक्रम-1 यान अब अंतरिक्ष में स्थापित हो चुका है. तृतीय चरण अब अपने कोस्ट फेज पे है और ये कोस्ट फेज अभी आप कैमरा व्यूज देख सकते हैं अपने प्रक्षेपण पर्दों या मोबाइल स्क्रीन पर, जहां पे आपको धरती का एक सुंदर दृश्य दिखाई दे रहा है।
As we can see on our screens right now, it's really amazing to see that Vikram-1 as of now is going along its intended trajectory exactly as expected. Our plots are really overlapping. The predicted velocities and the current flight velocities are exactly matching. And aren't you guys speechless right now?
I mean, yeah, मेरे पास शब्द ही नहीं है, मतलब ये मैं निशब्द हो चुका हूँ।
That's right.
इनको तो बहुत
We are approaching another point wherein S3 will separate.
और तृतीय चरण का प्रतिकरण भी हो चुका है।
And you see wonderful views of S3 separating. And now we have combined coasting has ended. And stage 4 will now coast on its own for the next 130 seconds. So stage 4 will now fly on its own, essentially. And
The control thrusters on the OM will be continuously turning on and off to maintain the attitude of the stage, making sure that it is pointing the right way. This also ensures that the antennas can maintain connection with the ground station and the satellite can be pointing in the right direction.
that's right. So one unique thing that has been done during separation is we've essentially fired all 4 of our Raman mini thrusters to sort of push stage 4 away from stage 3. And that just sort of guarantees that there is some minimum separation between the two.
अब आने वाला जो चरण है वो द्रव्य प्रणोदन पर आधारित होगा, जिसको हम कक्षा स्थापन या समायोजन खंड ऑर्बिट एडजस्टमेंट मॉड्यूल के नाम से भी जानते हैं, जिसमें द्रव्य प्रणोदन की अवस्थाओं से संचालन होगा जो मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टेट्राऑक्साइड पे आधारित है। उसके साथ यान के ध्रुणी नियंत्रण के लिए, जिसे कंट्रोल थ्रस्टर्स कहते हैं हम लोग, रामन मिनी 50 न्यूटन, वो भी मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टेट्रा ऑक्साइड पर ही आधारित है। उसके अंतर्गत हमारे पास छोटे कोल्ड गैस थ्रस्टर्स जो कि नाइट्रोजन गैस पर आधारित हैं, वो भी कक्षा समायोजन खंड पे स्थित हैं।
And we've heard call out that S4 or stage 4 has ignited successfully.
और चतुर्थ और अंतिम चरण का भी प्रज्वलन हो चुका है।
The liquid engine has come alive over 400 kilometers above the Earth, beginning a burn that will last for more than 6 minutes. During this phase, the vehicle will steadily accelerate from about 6.68 kilometers per second to nearly 7.64 kilometers per second, delivering the precise velocity needed to achieve its planned 450 by 450 kilometers circular low Earth orbit at a 60-degree inclination.
60-degree inclination.
और यहाँ पे आप देख सकते हैं कि प्रक्षेपण नियंत्रण केंद्र में उत्साह का एक प्रसंग आ चुका है और आपके ऑन बोर्ड प्रक्षेपक पर्दों पर हम देख सकते हैं कि पेलोड्स या जो उपग्रह हैं उनका एक चित्र, यहाँ पे सारे उपग्रह अपने स्थान पर स्थित हैं।
That's right, Akhil. We've also had seamless transition from the port player to the Bogor station, and now we are receiving strong telemetry from the Bogor as well as the Yatharga stations in Indonesia and Australia respectively. The current altitude of the vehicle is 426 kilometers. Our target is near 450. We're traveling at 6.5 kilometers per second. And like we said earlier, OAM is essentially going to fire its Raman 2 engine for a cumulative burn time of nearly 6+ minutes. So this is the longest burning. It's the smallest in thrust, but it burns for the longest period of time. And it's all given to us by Raman-2, our main engine for this mission.
So yes, it must be a really amazing feeling, right? I mean, you and your team worked on this engine to get it going, and it is finally taking us to space.
Yeah, it's a feeling that's really hard to describe. Me and my team, we worked on this engine to get it going, and it's finally taking us to space. This engine wasn't an easy design. Raman-2 generates 1500 newtons of thrust, and it employs 3 different types of cooling. As if one wasn't enough, we had to put in 3. So we have regenerative cooling, then we have radiative cooling, and we have film cooling. And all 3 of these need to work seamlessly in sync to deliver this phenomenal outcome. So I'm kind of glued to the screens right now. You might just see me peeking over to try to see what the chamber pressure, what the thrust, and what the temperatures are like. But I think I might have to hold for a bit and look at that data in a little while. So while I was talking about Raman-2 and how difficult it was to essentially design an engine this small, like I said, it's a relatively small engine, and the cooling design on this was exceptionally difficult to manage because the engine has to generate a lot of heat during combustion, and the temperatures can reach up to 2700 degrees. That's pretty hard for any metal or any material to sustain. In fact, many metals would just vaporize into thin air at those temperatures. So to make all of this work, we employ something known as regenerative cooling.
S4 performance normal.
Yeah, and we've got to call out that the S4 performance is nominal. And so I was mentioning about the regenerative cooling, and the best way to understand this type of cooling is to imagine
14 minutes.
multiple tubes joined side by side and then arranged into a circular fashion to form the thrust chamber. And these tubes, they need to be very, very thin to exchange heat effectively, which means that manufacturing is usually a challenge. And even after the temperatures would still be too high for normal metals to handle. And for this exact purpose, we employ something known as film cooling. And even though it sounds like a fancy name, it's just involves injecting fine jets of fuel along the walls of the chamber to effectively add a barrier of colder gas between the combustion chamber and the metal walls. And essentially, one question I get asked very often is, if it's like that, then why is it called regenerative cooling, right? The whole thought process is the tiny tubes that we just talked about. Those tubes
Performance normal.
Plus 15 minutes.
और यहाँ पर हमको मिशन नियंत्रण केंद्र से संकेत मिल रहे हैं कि चतुर्थ चरण का भी परफॉर्मेंस सामान्य है और अभी यान 450 किलोमीटर की ऊंचाई तक पहुंच चुका है जो कि उसका निर्धारित कक्षा है और कोस्ट फेज प्रारंभ है.
जी हाँ, and it's traveling at 7.3 kilometers per second at an altitude of 453 kilometers right now. So coming back to the regenerative cooling point of things, the tiny tubes around the thrust chamber of the engine essentially have fuel pumped through it. And we've got confirmation that we have cutoff of the Raman-2 engine, which means that, and we have separation of the Solaris satellite and the Scope satellite. Both satellites have been deployed successfully, and we have reached space on our first attempt successfully.
इतिहास में पहली बार एक यान ने अपने प्रथम परीक्षण उड़ान में ही उपग्रहों को उनकी निर्धारित कक्षा में स्थापित कर दिया है.
And now comes something very, very interesting. You can see on your screen from on board the cosmic bloom and the micro art And we have sun rising behind it. It is the dawn of a new space era.
ये एक नए अंतरिक्ष युग का प्रारंभ है. सूर्य के किरण ने ये प्रकाशित कर दिया है.
Skyroot has actually completely redefined orbital flights, I guess, forever.
Yes, अवश्य. ये कथन बिल्कुल
Plus
सही है.
17 minutes.
So right now we are awaiting the Cosmoser satellite to perform.
Vikram-1 Aagaman mission is a grand success.
And we've heard call out from the mission director that the Aagaman mission is a grand success.
सफलतापूर्वक प्रथम मिशन आगमन ने इतिहास के पन्नों में अपना नाम अंकित कर दिया है.
Hello space, we have arrived.
Skyroot has arrived.
Thank you for joining us today.
Thank you for being with us on this historic journey today. With Raman 2 and Vikram-1 now safely in orbit, we are not just reaching space, we are opening space for all.
आज की इस ऐतिहासिक उड़ान में हमारे साथ जुड़ने के लिए आपका हार्दिक धन्यवाद. विक्रम-1 ने सफलतापूर्वक सारे उपग्रहों को कक्षा में पहुंचा दिया है और भारत के अंतरिक्ष सफर में एक नया उज्जवल अध्याय खोल दिया है. धन्यवाद. जय हिंद, जय भारत.
Good afternoon. Good afternoon, everyone. We'll let them celebrate. Good afternoon. I am privileged to formally announce that the first ever Indian private sector launch has been successfully completed. Not only did Vikram-1 meet its mission objective, which was simply to clear the tower. It went all the way up to 453-kilometer orbit, successfully completed all the tasks, and something that is way beyond expectation for the very first orbital launch ever taken by India private company. There is not much more that I want to say on this occasion. I would like to invite Pawan and Bharat to talk about their journey and how they feel today, this momentous milestone that Indian private sector space initiatives have had. And I would like to thank everyone involved in this, of course the Skyroot team. The Skyroot team has worked day and night to make this day happen, ably supported by the team from SAR, from extended ISRO and from InSpace. So thank you everyone for giving India this proud moment. Thank you.
बात करेंगे वो एक फोटो लेंगे
सर।
हेलो, नमस्ते। कौन बोल रहे हैं?
हेलो, we are Pawan and Bharat from Skyroot.
कौन बोल रहे हैं?
Sir, we are very privileged to hear you. First, your voice after the success.
भारत और पूरी टीम, सबसे पहले तो आपको बहुत बहुत बधाई। दो काम किए हैं, एक तो आसमान में नए पौधे गाड़ दिए हैं और दूसरा जमीन में भी उस रूट्स को आपने मजबूती दी है जो देश के नौजवानों को आगे आने की प्रेरणा देगी। और मुझे ये सफलता के लिए तो आनंद होना ही होना था, लेकिन आप लोगों ने जिस कमिटमेंट के साथ मेहनत की और मैं जब आपके इंफिनिटी कैंपस के उद्घाटन के लिए आपके साथ जुड़ा था, मेरे तो मन करता था मैं पहुंचूं, लेकिन पहुंच नहीं पाया, लेकिन आपके साथ वीडियो से जुड़ा था। और आज भी मैं इस पूरे लॉन्चिंग कार्यक्रम को देख रहा था। कब से मेरा ध्यान जो गया, आपकी पूरी टीम 25-30 साल की दिखती है, ये मुझे और खुशी दे रही थी। शुरू में आपके चेहरे पर चिंता भी नजर आती थी, लेकिन फिर मैं देख रहा था कि खुशियों से माहौल भर गया। मैं आपको, आपकी पूरी टीम को इस महत्वपूर्ण निर्णय के लिए और महत्वपूर्ण सफलता के लिए मैं बहुत बहुत बधाई देता हूं। जब हम स्पेस को प्राइवेटाइज करना चाहते थे, तब मेरे सामने कई सारी आशंकाएं रखी गई थी। ये तो हो नहीं सकता, कैसे करोगे, वैसे करोगे, लेकिन मैं इसको आगे बढ़ता ही गया। अब आपके कारण मेरे उस निर्णय को ताकत मिल गई है। अब मेरी टीम भी स्वीकार करेगी, यहाँ देश के नौजवानों पर भरोसा करना चाहिए, उनको काम देना चाहिए, और वो करके दिखाते हैं। आपने काम करके दिखाया है। मैं आपकी और आपकी टीम को फिर से एक बार बहुत बहुत बधाई देता हूँ।
Hello, sir. Thanks a lot for your wishes. And our team, entire team of Skyroot, more than 1,000 people are here in Sriharikota and listening to you. Our hearts are swelling with pride, and this means a lot to us.
देखिए, ये मिशन आगमन है। अब आगमन को तो और आगे बढ़ते ही जाना है।
Sure, sir. और सर, आपका कार्ड जो आप भेजे थे, that has successfully reached space and you have written Vande Mataram. So Vande Mataram is in orbit.
देखिए, मेरे लिए बहुत खुशी की बात है, जब आपने सुझाव भेजा तो मेरे मन में कई विचार आए थे, लेकिन आखिर जब मैंने सोचा मैं सिर्फ वंदे मातरम लिखूंगा। उसके दो कारण थे। इस बार हमारा देश वंदे मातरम के 150 वर्ष मना रहा है, तो मैं चाहता था कि इसको एक नए तरीके से मनाएं, और वंदे मातरम ही था जिससे देश के नौजवानों को हमेशा देश के लिए जीने मरने की प्रेरणा देती। और आज वंदे मातरम हमें देश के लिए जीने की ताकत देता है, और आप लोगों ने जी करके दिखाया है। आपका जो कुछ भी मिशन है, मैं इसको एक प्रकार से वंदे मातरम मिशन ही देखता हूँ कि भारत माँ की गरिमा को नई ऊंचाइयों पर पहुंचाना, नई पीढ़ी को टेक्नोलॉजी को लाभ देना, और नई पीढ़ी को टेक्नोलॉजी में आने के लिए प्रेरित करना, इन हर प्रकार से। और उसमें से मेरे मन में विचार आया कि लंबा कुछ ना लिखूं, सिर्फ वंदे मातरम मेरे भाव व्यक्त करूं। और मुझे खुशी है कि कल आपने उस बात को मीडिया से भी शेयर किया, और आज इस सफलता के साथ वंदे मातरम का भाव भी नई
Thank you, sir.
मैं आपकी पूरी टीम को बहुत बहुत बधाई देता हूँ और जल्द से जल्द आपको मिलने के लिए निमंत्रण भी देता हूँ।
Thank you, sir. Thanks a lot. Thank you, sir. We are privileged to hear you. I'm privileged to have your blessings. Entire team of Skyroot and entire India is really proud of your initiative to start the space program, open it up to private sector, and now we see historically, first time probably a private company have built and successfully reached an orbit in the first attempt. Thanks a lot. It's happening from India, and this is a 100% designed in India rocket, 100% manufactured in India, and I think thanks to entire team Skyroot, whose average age is just 28 years.
जब मैं आत्मनिर्भर भारत की बात करता था तो ना समझी में कुछ लोग उसकी मजाक उड़ाते थे, लेकिन आज आपने सिद्ध कर दिया कि हम इस क्षेत्र में भी आत्मनिर्भर बनने में समर्थ हैं और आपने उस समर्थन को दिखाया है और मैं पक्का मानता हूं कि अब सबूत हमारे सामने है, साक्ष्य हमारे सामने है और ये आपकी टीम ने करके दिखाया है।
Thank you, sir. Thank you.
आज तो आपकी टीम खुशियां मनाने में लग रहेगी।
जरूर सर, and in fact हम जब 2018 में स्काईरूट स्टार्ट किया था उस टाइम पॉलिसी नहीं थे, there was no फंडिंग एनवायरनमेंट और प्राइवेट सेक्टर में टैलेंट भी नहीं था और हम फिर से हमारा जॉब्स छोड़ के स्काईरूट चालू किया था एंड नाउ वी आर वेरी प्राउड दैट the government is enabled us and opened up the sector to private players, and now we stand as India's first private company which have launched a rocket to orbit and also created a global milestone, all from India, with a fully Indian team, 100% built in India. Thanks a lot for enabling this journey and also setting a vision, big vision for 50 launches in 2030. Definitely, I don't see it as a challenge, sir. Thanks a lot for your encouragement and looking forward to meet you, sir, in person.
आप आगे बढ़िए, मैं पूरी तरह आपके साथ हूँ और आपको तो आगे बढ़िए नहीं कहना चाहिए, मुझे कहना चाहिए और ऊपर उड़िए।
Thank you, sir. जरूर सर, thanks a lot, sir.
चलिए बहुत अभी आपको कुछ न कुछ काम होगा, लेकिन सबसे पहले मेरा आपकी टीम को सचमुच में मुझे देखकर तो खुशी हो रही थी कि इतने मेरे देश के नौजवान क्या कमाल कर रहे हैं, यही मेरे लिए खुशी की बात थी। बहुत बधाई फिर से एक बार और बहुत शुभकामनाएं। और आपने जो टारगेट तय किया है वो समय से पहले टारगेट पूरा हो गया, मुझे पक्का विश्वास है।
थैंक यू सर, थैंक्स अ लॉट। हम जरूर कोशिश करेंगे। थैंक यू come. Absolutely no words. Absolutely no words. Go! It's so heartening to hear the Honorable Prime Minister talk so highly about Skyroot, so highly about India's youth. I think this is a historic moment, not just for Skyroot, for India, and also entire global space sector. In the first attempt reaching orbit, I never thought it was possible, and Skyroot team made it possible. Big shout out to this phenomenal team which made it happen. And in fact, this launch was nothing short of a suspense movie. We all experienced the highs, and never have we seen such suspense. And I think it's all worth it at the end. And I think really happy today, and that we have achieved something very rare, very unique. It shows the potential of India's talent. And today, in fact, we stand here at one of the best spaceports in the world, and we are very proud to launch Vikram-1 from the most versatile launch pads in the world, and really thank ISRO for enabling this. And more importantly, I would like to appreciate and also thank entire in-space team, which has efficiently authorized this launch. And in fact, I've seen countries, companies waiting for launch authorization for so much time, and India has proved it that government is the most efficient. And in fact, they enabled this launch in record time. There was zero delay in authorizing India's first private orbital launch. And like I was telling the Honorable Prime Minister with pride, this is a 100% designed in India rocket, 100% made in India rocket, built by 100% Indian people, for India, for the world. So in fact, I've written a speech, but I'm just out of words. And I'm so happy today, and really, this journey is only possible because first, Team Skyroot, of course, the government, the Honorable Prime Minister for his vision to open up the sector to private players. And then now today, India is proud to be the fastest growing space tech ecosystem in the world. And now we achieve one of the biggest milestones ever in India's space sector. First private orbital rocket reaching orbit in the very first attempt. It still feels like a dream, and you all made this dream happen. I have no more words. And really appreciate everybody making this happen. In fact, we can see, I think all the hearts were racing up. It was not Skyroot, it was not InSpace, it was not ISRO, it was not the people watching, the public watching in the gallery, people watching online. Everybody's heart was beating for India, everybody's heart was beating for Mission Aagaman. And we made it happen. It's one nation, one mission for the world. Thank you.
So I request all the Skyroot folks here just come up on the stage. Don't leave any inch remaining on the stage. Please occupy the stage now. So as mentioned, simply we wanted to prepare something, but there's just simply no words. I just wanted to send the deep sense of gratitude to InSpace for being the enabling pillar.
आज पूरा देश देख रहा है, धरती हो या फिर अंतरिक्ष, 21वीं सदी को भारत की सदी बना।
Ladies and gentlemen, India is now building a company that is about to compete with SpaceX. Look at this rocket. It is standing on a launch pad in Sriharikota. And right now, as you watch this video, it is about to do something that no private company in India has ever done in 78 years of independence. This is the rocket of Skyroot. You see, for most of history, the world told India to stay in its lane. Grow your food, run your factories, answer the world's phone calls. But when it comes to the stars, they said leave the stars to the big boys. Space was always meant to be the playground of the West, and we were only allowed to watch what the big boys do.
A country that has extreme poverty, really? Should they really be spending this sort of money on a space program?
But a few brave men and women put in their blood and sweat, carried rocket parts on bicycles, turned a church into a lab to pioneer India's first leap into space. And now, standing on the shoulders of those giants, two ex-ISRO engineers with no money, no connections and no legal permit somehow decided to build a company that offers something even SpaceX doesn't offer. And today, right before the launch, we have the co-founder of Skyroot, Pawan Kumar, at the podcast. And in this episode, he teaches us why is the whole world suddenly going gaga over space, how does a rocket company actually make money, as founders, why is space the next big goldmine of opportunity for normal people like you and me, and why is it so important for India? Before we move on, if you're running a manufacturing unit, Odoo has a very special announcement for you. As a manufacturer, your biggest roadblock is outdated technology. 99% of manufacturers keep tracking raw materials in one Excel sheet, they run production on another tool, they do quality checks on paper, and their floor team keeps calling them every 2 hours just to ask what to build next. This is exactly why orders pile up, materials go missing, and your data gets scattered across 10 different sheets. This is exactly where Odoo comes in. Odoo's manufacturing app helps you run your entire factory floor from one clean, centralized place. With a single platform, you can plan production, schedule workflows, adjust deadlines, and balance capacity effortlessly. You can also set up engineering change orders for products, giving your team a collaborative space to create, review, and approve bills of materials. The shop floor view gives you a bird's eye view of every workstation, along with key work instructions and quality check information at each stage. At the back end, you can track component usage, monitor time spent, and maintain complete visibility across the entire production process effortlessly. And lastly, with the master production schedule, you can forecast order production ahead of time and keep your unit ready with all the required components based on historical data from Odoo sales. And the best part is, every app is seamlessly connected so that your entire workflow runs in one place. From Odoo purchase for vendor bills to Odoo repair for handling defects, everything works together smoothly. And guess what? You can get started with Odoo's manufacturing app for free today. And as your business scales, you can access the full suite for just 580 rupees per user per month. So if you're serious about scaling your manufacturing with precision and clarity, click the link in the description and get started with Odoo today. Hi Bhavan, welcome to the Indian Business Podcast. Ever since SpaceX went IPO, everybody's going gaga over space. And when we were doing research about SpaceX, we found out the amazing story of Skyroot. And today, as you can see, you're a star over here, which is why half the team is sitting here to witness your journey through your lens. So firstly, thank you so much. It's an honor to have you at the podcast.
Thanks, Ganesh, and hello, everybody. A pleasure to meet you.
Amazing. Pawan, tell me something. What exactly has happened in the last 15 years because of which every Tom, Dick and Harry is launching a rocket? SpaceX launched 165 rocket. Blue Origin is about to launch 15 to 16 rockets. How is this happening? That every alternate day we're having a rocket launch.
First is like the demand has become so high, especially for launching communication satellites, which can give internet to billions of people directly from space. And then like there's a lot of Earth observation satellites where like satellites have cameras, and then they click images, and that analytics from these images are used by various industries. For example, the solar panel. 15 years ago, this is the statistics, right? So 2010, it is 200 rupees per watt. And in 15 years, it's become close to 10 rupees per watt. This is like a massive production scale, and also advancements in tech, and all coming together and making it like, significantly orders of magnitude less cost. The same transformation is happening in rockets as well, where rockets are getting reusable. So traditionally what happens is that they're in multiple stages. That means like the Earth gravity is so high, so high, that the rocket needs so much energy to reach to space. So rockets, what happens is that as they go up, they have to shut down mass. So they have to, so it's consumed, some part of the rocket fuel is consumed, then that part is separated out. Because you don't need to carry it all along to the orbit. Then only you can carry the payload or the satellite. So you have to shed your mass as you go up. That's the only way you can beat Earth gravity and reach orbit. So that's why like what happens is that the existing technology which we have, we use fuels. Fuels like, most of the rockets use either solid fuel or they use kerosene as the fuel. Right now, for example, SpaceX rockets, new rockets, they use methane or LNG, as the fuel, and then oxygen, liquid oxygen as the fuel. So all these fuels, has to carry in the tanks of the rocket, and then they have to burn. Once the fuel burns a part of it, that portion of the rocket you have to separate. The final stage falls in, goes to orbit, or the third stage goes to orbit. So that way what happens, it sheds the mass. So it's in multiple stages.
And tell me something, Space is a foundational industry. Just like when internet cost went down, several industries popped up. I am assuming that when the cost of launch goes down from $2,700 per kg to maybe $100 per kg, revolutionary things might happen. My question is, which are the top 3 industries that do not exist today, which will come into existence and thrive 10 years later?
One is what we all are speaking, the whole at global scale we are all speaking is AI. So there is, according to me, there's no border between AI and space. So literally, the future of compute is in space. Because you have almost 7 to 8 times more energy per unit area in space, because here on Earth you get only 6 hours of, for example, solar, right? And in space there are orbits where you have 24/7 exposure. Continuously you are exposed to the sun, and you can actually rotate your spacecraft in the optimum angle so that you get maximum energy. There's no atmospheric filtering. So that is, I think, it's like cheap energy from the sun. If you're able to launch at scale, build spacecraft at scale, and the lowest cost of compute will be in space. And then you don't need water to cool, you don't need real estate, you don't need to buy land, large parcels of land. It takes several years to build a data center on the ground. It takes, even if you have launch and you can build spacecraft at scale, you can actually launch gigawatts per year very easily.
So first industry that's going to boom is the AI industry, specifically the data center layer, where we'll put data centers in space. The challenge is
launch cost should go down. So today's launch cost, like what we're talking about, is the lowest numbers today we achieved is like $2,700 per kg. At that you can't build. Compute on terrestrial compute will be far superior, like in cost compared to space. Space compute. But that has to go down to like few $100s per kg. That's when like the switch happens where on paper it can be space compute can be cheaper than on ground. Then you can scale very high in space. Space is massive. It's like 3-dimensional space. It's like massive, right? So you can put like giant data centers as big as you want to, without need of acquiring real estate. No issues with local agencies, and and also preserves Earth, right?
Now that we've set the premise for what's happening in space and why it's so exciting, I want to understand. In 2018, you started this company when it was illegal to launch rockets in India. Privatization had not even happened in 2018 in this particular industry. And you left your job at ISRO to launch a company which the government also never intended to exist. How does that make any sense?
I had ambitions to start a company from childhood, and then I went into IIT. IIT, there was in 2007 to 12, I did both my bachelor's and master's there, and then there was a lot of entrepreneurial vibe somehow. Probably that's where the Flipkarts of the world are starting. I wanted to be I was a mechanical engineer. I wanted to work on the toughest machine built by humans, and for me, hands down, it's a rocket. And then I was really inspired by ISRO. We Indians build our own rockets. Only 5-6 countries in the world have that capability, and we launch it regularly. You have like PSLV, GSLV, LVM3. You have so many rockets which we are building from scratch from India, and we are launching. Right. So this I was really inspired, and then ISRO came to campus. I think one of the early times it has come to campus. It really comes to campus, and then I thought this is where I need to go. I just made up my mind. I didn't sit for any placements. And I luckily got selected and ISRO. I became a scientist at ISRO, and I still remember the first day I entered the ISRO factory. It's a massive hangar with large rocket stages, and it really got goosebumps. And this is where I need to be. And though I got a degree from IIT, but I really felt that I became an engineer after joining ISRO. It was like when you actually do hardcore engineering work by yourself is really when you graduate as an engineer. Right? So I was so really so engrossed. I learned everything I could, how rockets are built, what people are doing across the world, why we are using this technology, why not this technology, what is the evolution of technology, what will be 10 years down the line, 20 years down the line, what was in 1960s. In fact, at a point of time, I wanted to settle at ISRO, because I settle and retire at ISRO, which most people do. 99.99% of the people who join ISRO retire at ISRO.
But what makes ISRO so special?
I mean, it's probably the only deep engineering, company in India, which is like, does hardcore tech development, fundamentally, everything from scratch from India. And then there's a lot of pride associated with it, right? You launch to the moon, there's Mars, you launch to Mars. India became the first, ISRO made India the first country in the world to reach Mars orbit in the very first attempt. We first country in the world who landed a spacecraft close to the surface of the South Pole of the moon. We went to the sun. We are the most frugal space program in the world. We went to Mars at less than the budget of the movie Martian. So that's the achievements which we have done in a very modest setting. If you see the history of the Indian space program, we started in a very small, a fishing village in Tumba. I had a very great opportunity to work in that place at the time at ISRO. And then from there, a small church, Dr. Vikram-1 spawned a small team there, and then brought people from abroad. Actually, at that time he brought people from who studied in Purdue University and all, PhDs except brought them, and then they started the initial set of scientists started building rockets, started launching on the shores of Tumba, small rockets. And then now they scaled to, we scaled as a space program to go to, moon, Mars, sun, and now we're going to launch our own astronauts into orbit. It is a phenomenal journey of India's, space program.
What are the values that Vikram Sarabhai instilled in ISRO, which makes ISRO so special that they're able to launch a rocket at less than the cost of a Hollywood movie?
Yeah, I think one thing is that scientific temper.
What do you mean by that?
It's the space is brutal. I told you the environment is so brutal that anything can go wrong. A small bolt can make a whole rocket fail. It's so expensive that it has to work every time perfectly. It's like the hardest engineering, one of the hardest engineering challenges, right? So what Dr. Sarabhai has brought in that great culture of scientific temper, or the engineering temperament, the attention to details in every people. Very people in ISRO are highest levels of integrity. For example, there's something wrong. It's highlighted, it is discussed widely. There is a forum for open discussion. It's celebrated. Even if something fails, it's accepted. It's okay. It's part of the development process. Keep doing it again and again. And then that national spirit, so that we have to do for the country. We have to take forward. We have to be among the best in the world. Because we know that resources are very less. For example, the entire budget of ISRO so far, all cumulatively add together, is less than 1 year budget of NASA.
That's amazing. And if your job was so good at ISRO, why did you leave and start Skyroot?
In fact, I was a part of the team, where the largest rocket of India was being developed. This is a rocket. I have a very personal connection with this. I was part of the team which was involved in the development of this rocket, and I was part of these first 2 missions, successful missions. Now it's turning into the workhorse for the country. Almost every mission so far was successful. The same rocket which launched the spacecraft which landed near the South Pole of the moon, first time in the world. And very proud to be associated, with this rocket. I wanted to retire there, but then one fine. Like a lightning strike, So it came like one strike. Why can't we build a rocket company from India? Because I had entrepreneurial ambitions, and rocket tech is my calling. Right, so it's like a marriage of 2 passions, and then suddenly felt like this is where my calling is, and then of course the moment I got the thought is literally jerked, saying that it's very difficult, it's not possible, for the reasons we told, because there's no policy in India which enables this, and there is no investment which is happening is unprecedented. There's no fund which has a thesis for space, right, and then there is no talent in the private sector. Right, you have to build a lot of things from scratch. Right, so there's a lot of things which the odds of it looks like, but then that odds of failure seem very high, odds of success seem very low. But then I felt like that is the opportunity. And everything is there in a platter, right? Building a rocket company is far easier. Nothing is there. That's when you have to take the first step. Right, we took that initial steps. Then we became the first company which is signed an MOU with ISRO, where we got access to all the test facilities once the policy was announced.
Oh, wow.
And policy was announced in 2-3 years. I thought it will take 10 years. I was all in, let it take 10 years. We'll persist and make some progress. Of course, you can build a rocket, but you can't launch a rocket. So you can build it.
So you thought of just building it?
Yeah, building it, waiting it.
That the government will allow you to launch it.
And also it's a chicken and egg problem. Unless you actually build the momentum. Why would what is the incentive of the government to open up the sector. When there is no commerce which is happening, there's no benefits which can come. So today, $600 million is invested in private space just mostly in the last 2-3 years. And then there are at least 5,000 plus employees. High-tech employment is being generated in the entire country in the space sector. Just for you, just imagine how next 10 years will look like.
What exactly is Skyroot's business model? Who pays you money, and how do you intend to make a profit?
We are like a logistics company to space.
Okay.
Which is very high-tech logistics. You think of it as rocket science. So literally, so you build a rocket and you launch a rocket. You put a satellite into orbit. The satellite company pays us for this transportation to space. It's a space transportation service. That's what we do. And then why do they pay? Because they're generating a lot of revenue through communications, through Earth observation. So communication satellites give communications to the Earth, across various regions where, there's no other way to connect. The satellite is the only way to connect.
But how can somebody make money through Earth observation?
Very good question. So it sounds very technical and research word, but Earth observation is a very large industry. It is set to become 30 billion by the end of this decade. Is next 5 years. And what it does is that basically these satellites have cameras in space. They click images of Earth, and these are various technologies. There are images. There's something called radar satellites, which can image 24/7. In the night, through the clouds, it can image Earth. Right. So this can be used for example, defense. Defense is one of the largest users of Earth observation. You safeguard our borders. You track what is happening across on a regular basis, right? And 24/7, right? Surveillance is a very big application, for example. And the other thing is that agriculture. For example, when you want to do precision agriculture.
What is precision agriculture?
So it's for example, if you want to irrigate your crop, right? So generally what we do is from experience, the farmers, water is put, and generally water is also subsidized. So you use a lot more water than you actually require most of the times. But actually space cameras are so sensitive that you can even detect even a 0.1 Kelvin temperature difference. And then when plants' leaves become dry, you know when to irrigate. When is the right time to irrigate the plants and exactly how much water to put. Right?
What are you saying?
Yeah,
because of the camera.
Yes. So that's the beauty. So see, they're so precise. This is all technology, marvels of technology.
So are you telling me that a camera from space can detect pest in plants?
Absolutely.
From space?
Yeah. That's the beauty of space tech, And then so that is farmers using it, and then fishermen. India has done a phenomenal job.
Fishermen?
Yes. So in fact, ISRO is one of the biggest contributions of ISRO, I think, to common man in India, for example, which less people know about. Is there's something called potential fishing zones, PFZ, which is identified by ISRO satellites. And they identify, they have a model which can identify where the right shoals of fish are. For example, fish will be highly generally around where probably there's more food for them. Water is warmer, whatever be the reason. So they identify, they map the locations where there's high potential of, that's why they call potential fishing zones. And this is released by radio, or the information is actually displayed on a very, very, regular basis to the fishermen on the ground. And then they save billions of dollars of fuel, searching for fish, which traditionally is done. So the application for space is insurance. For example, there's a crop damage which happens at a particular point. It's very widely used. Most people don't know, but for insurance sector, it's space very common. What they do, they take satellite imagery, they identify if this disaster really happened in that area, they confirm it immediately. Insurance payments happen. No need to go, no physical verification, no going, nothing. So all happens at global scale with space images. And in fact, I've heard recently that somebody is using even disbursals for loans of building a home. One floor is built, satellite checks it, and you disburse. Next floor is built, or multiple floors are built. Right? So it's completely transforming. So today, what happens is the applications which space can bring, we are barely scratching this. Even bigger impact is communication. Billions of people do not have access to high-speed internet. So just get connected with space.
So these are the companies who pay you money, and you take their objects to space.
Correct.
Crazy. Now, how much does it cost to make your rocket, and how much money do you actually make?
Yeah, I mean, see, think of it like, our rockets are like a niche segment, we are like cabs to go to space. We are like the Uber to go to space. That means like customers satellites who want a very unique orbit. Somebody wants a particular angle to the equator. They want to launch a particular angle to the equator because that gives the maximum coverage to their region of interest. When multiple satellites come together, go to regular orbits, regular hubs. But what we do is like we go customized locations in space, right? So then the customers actually book the entire rocket, like booking a cab, and then ride on the rocket and go to the specific location that gives the best coverage and maximum ROI for them. That's what we do. And this is a premium service, naturally, and there's hardly any player doing it today. There's only one US company doing it. That's it, and that's a 20-year-old company. It's the only thing which exists today to go for like similar to an Uber to space, right? That's what exists today. And now we are getting into the market soon, and with our launches. And then today, for our kind of rockets, you can make as high as 100 crores per launch. For getting there, you'll have to establish great reliability. You have to establish, good payload capacity to go to orbit. If you do like 20 launches, it's 20 into 100. It's 2,000 crores. You can do as many as you can.
Great math.
So you can do as many as you can build, right? So and that's a challenge. Not easy to actually launch a rocket successfully. It's not easy to even scale a rocket to several tons a year. Yeah.
How exactly are you different from SpaceX and ISRO?
Yeah, like I mentioned, they build bigger rockets. Like think of them like a train or a metro. It's hub to hub. There are certain orbits where 90% of the traffic is. Right, and they launch. That's why like SpaceX does almost $5 billion revenue by launching only 20-30% of their launches to others. And the rest of it they launch their own Starlink. Right, that's a massive scale of revenue because they launch majority of the traffic of the world to orbits which most people want to go. Right, but we didn't want to compete in that space. So for that, and also beauty is that for that you have to build a huge rocket, massive rocket, spend like huge amount of capital. The chances of survival is very, very thin, and that's why what we found a niche in the market, like the Uber to go to space or the cab to go to space. We have like this unique orbit requirements, so that way most of the satellites are below 300 kilograms. More than 90% of the satellites are below 300 kilograms. They're all called small satellites. Previously, satellites used to be the size of the room. Now they're like size of a suitcase, and the size of a small mini fridge. Right, so these satellites can do a lot more things, than what satellites used to do before. Like our smartphones got smaller, right? Satellites also got smaller. So the satellite below 300 kg. So why can't we build a rocket which is a capacity of 300 kilograms, and we have a version of the rocket which is up to a ton. So most of the satellites get covered in this, and then many of them will require unique orbits, and then we launch to them, as like a premium service in the market, and then that's where we turn. And in fact, it's very challenging to build a small rocket as compared to a big rocket.
Oh, really?
Yeah, because gravity is brutal. So it's like when you build a small rocket, you have to optimize in grams. Everything counts. The moment you add the mass to reduce your risks. For example, you build a rocket. How do you reduce the risk of failure? You increase the thickness. You add more components. You add more redundancy. You have no scope to add all those things. The rocket becomes big and expensive.
Then why did you not build a big rocket directly?
So you need to raise $500 million. And then it's very tough. The moment you build a small rocket, you already build it. You have already undergone the toughest journey, and then that prepares you to build a big rocket in very less time. And generally, people say that when Skyroot started, right? People at that time, the trend in the market used to be like, if you're a billionaire and you want to become a millionaire, start a rocket company. So it's like that, But
now it's like if you're a billionaire and you want to become a trillionaire, launch a rocket company.
You're right. Then we'll build a rocket company, and probably that'll be the toughest journey. But yeah, that's the only way you can create $1 trillion. That's how Musk has done, right? So it's crazy when the narrative has changed, and the Rocket Lab we built another billionaire. So Peter Beck is like phenomenal entrepreneur. So he doesn't have a formal education, but he's his vision was to build rockets from school, college. He went, learned in workshops. He's come to in a country in New Zealand with no space program. And then he built like the largest space companies in the globe. It took 20 years to get there, but it's a phenomenal, incredible journey, right? So this is the journey of space companies is like literally, treading the unconventional path, pushing the boundaries of human potential. It's just so challenging, but yet fun. There's a unique journey which you can go, so satisfying.
That's crazy. Pawan, how did you raise money for Skyroot? I heard that Mukesh Bansal put in 10 crores.
No, so see, basically, when I want to start the company, right? Frankly, I had ambition to start a company, but absolutely no clue how to raise capital. And I have no money also. So what I did, actually, I Googled. What is fundraising? Kya karna hai? What is term sheet? What are the terms typically? Like, how do you people raise capital? Why does an investor put capital? Frankly, I thought maybe it's a loan, or I have typically no idea, right? So then, like, after Googling and learning, then okay, this is how investments are done. It's fair, exchange shares of the company, for the capital coming in. So I had literally no connects, no contacts, nothing. So what I did is I went to LinkedIn. And then in fact, like, my friend, initially we had like few friends, trying to, build the company initially. There's my friend, like, who said, like, who got an idea that, like, let me ping Mukesh Bansal. He pinged Mukesh Bansal. He immediately responded. We met the next day, if I remember rightly, and then, like, we flew to Bangalore. We had a conversation, and then it's like less than an hour of interaction. And then he committed that I'm going to invest.
He gave you 10 crores in less than an hour.
Decision in less than an hour. And then, like, in just few weeks, we had the term sheet, money in the bank.
What was your pitch?
Nothing actually. I mean, like, just told, like, this is a phenomenal new industry. I'm quitting our jobs. Me and my co-founder Bharat. Quitting our jobs, very safe jobs, very respected jobs, like, so quitting our jobs, taking that risk, leap of faith, and then this is like a great business opportunity. SpaceX is doing phenomenal work in the US. It's just like, in the space is just going to open up at some point of time, in India, and India has strong foundations. And then we're taking the risk, bold risk, in building the technology in India. Costs are extremely low, and ISRO has already proven it. Right? So the fundamentals are really strong. And then typically a fund may not be able to take the risk at the early stage, but because Mukesh was very passionate about deep technology, and he's passionate about space, and then he liked the way, like, we quit our jobs, willing to take large risks despite no policy, despite no funding environment, going to take that brutal startup world and then going to build something as big as as bold as building a rocket from India, right? So he generally entrepreneurs are risk taking. Naturally, that's how entrepreneurs are, right? So for an entrepreneur who is very passionate about technology, is passionate about space, it felt like something which you want to probably give back, or wanting to contribute, wanting to be part of, and then, like, it excited him, and then and then, like, he took that leap of faith along with us, and he wrote the first check.
Now, Pawan, before we say goodbye, I want to ask you two questions. Firstly, if an investor is watching this episode, which are the 3 domains in space that they must look into?
So one is definitely, launch, because the world has less launch vehicles and more things to launch, and probably is the most brutal part of the space industry. That's the reason why we have, like, just less winners. We have SpaceX, Rocket Lab.
So is this only a capital problem or a R&D problem?
Oh, never a capital problem. So that means you can throw all the money in the world. You can never succeed in building a rocket company.
And how can an investor actually test, without knowing rocket science, whether a company is even worth investing or not?
That's exactly why all our early investors are entrepreneurs.
You don't know.
So you can never know. So what happens is that, you can't have a calculation. You have, for example, if I invest, I look at the founders' energy, how they think, how they execute, what is their approach to execution, what is their approach to technology problem solving, what is the energy they have, infectious passion they have. So they'll figure things out. right? For example, let's say today AI has removed so many jobs, removed so many industries are completely shattered. But the best entrepreneurs are going to be so agile, figure out a problem in that crisis, and build a phenomenal company. Even just pivot and make a phenomenal company. So it's basically not the industry or the environment; it's the people who are actually building the company. So who can actually detect those sparks early on? Who has potential? Maybe they're phenomenal. They speak phenomenally. They do. Maybe most founders fail also, right? So that way, I think the knack of identifying early entrepreneurs is I think the early phase what investors should do.
So first is launch. The second category would be?
Second category would be definitely in-space services.
In-space services. Like, for example?
Means like in-space services means there will be a lot of space assets. As the launch gets cheaper, there will be a lot of things going into space. Satellites, data centers, communication satellites, Earth observation, and then you'll have space stations, all that in orbit. So now what happens is that we repair everything in the home, we repair every electronics item in the home, every appliance we repair. But there is huge asset, costing millions of dollars, sometimes billions of dollars. You have to repair it. You can't go waste. So go service it. So you have a robotic spacecraft going service it, or maybe even astronauts doing a spacewalk and servicing it. So in space services, and then what happens is what causes the satellite die down? Fuel is gone. You put a limited fuel, even though there's no atmospheric drag, there's a little bit atmospheric drag. To compensate that, there's fuel continuously getting used. Once the fuel expires, then the atmospheric drag takes over several months, it burns down. So its satellite is dead. So you go refuel the spacecraft.
So you need an urban company, but for space.
Absolutely. Yeah. So that is the thing. And then another service is debris removal.
Debris removal.
So now, for example, US taken a very important step for space sustainability. They said that after satellite or spacecraft is dead, within 5 years you have to remove the debris. There's an option. You have to, right? And you have to explain when you put a constellation. You have to explain how you'll remove the debris. So this is all pre-planned. So now, if you want to remove the debris, you have to go. You have to have a space. Your satellite is dead. You can't do anything with the satellite. Either you deorbit the satellite, or if the satellite is dead, many satellites get dead because some component fails, and then the final aging is dead. So you have to have a robotic spacecraft which goes, captures it, and then brings it down lower altitudes, and of course compute in space. So compute in space is going to be very, very big, and then
which is basically data centers
in space, in various forms. And then that's also a big upcoming opportunity. So intelligent satellites in space, using that data for actionable insights to make things better on. Like for example, a fisherman, through satellite he gets connectivity, because in the deep sea you don't have any network. He gets connectivity and he also gets where the fish is there. Example, right? That's going to be actionable intelligence which is actionable, which improves lives here on Earth, right? So all this is also this is called downstream. Upstream is rockets and satellites which go there. Downstream is the service which comes, the communication service, the connectivity service, the Earth observation intelligence which you can use, right? All this is the other opportunities.
Understood. And my last question to you is, if a 23-year-old is watching this episode, what exactly should they do?
Yeah.
Study, work, whatever, to become a beneficiary of this space revolution?
So first thing is that nudge them to start something. Maybe space, may not be space. What's your calling? What is the problem you want to solve? Start a company. We need more and more entrepreneurs in the country, bold entrepreneurs in the country. Today we don't have deep tech at all. Recently, last year, is still ringing in me. When Piyush Goyalji said, "No, do we want is the future of country to become delivery boys or girls, or build fancy ice creams or cookies?" I mean, even though it sounded bit difficult to absorb.
But what can the entrepreneurs of India do if they made it legal only to launch cookies and not rockets?
Yeah, that's right. But now it's opening up. Now nuclear is the Shanti Bill has come, Shanti Act has come. Nuclear is open, space is open, robotics, everything is open, right? It's just no problems to solve for entrepreneurs. India needs more deep tech. India needs everything. India needs delivery at scale. For example, Zeptos of the world, now the Snapbits of the world, they all are required. They make lives better, right? And we also require deep tech at that vigor or even more vigorous. Right? We need companies building aircrafts, companies building drones, companies building robotics, companies building nuclear fusion reactors, companies building biotech companies building new drugs, artificial AI, space, defense. I mean, it should be vibrant deep tech economy. That's the future of India. And then there's a space which is unfilled. And the 23-year-old today, first thing, I think they should take that step, the leap of faith.
What should they study?
See, I think now education is more or less free. It's like you can chat GPT, you can Claude stuff, whatever. You can get
even rocket science.
Yeah, I mean, like Elon Musk's learned rocket science on the go.
But he's Elon Musk.
Why can't you be Elon Musk? So in fact, you can learn. I mean, anything can be learned.
So you're saying that anybody can be a self-taught rocket scientist?
See, I think the best people in the world are self-taught. And in fact, everything else is like a format for self-teaching better. For example, there could be like a podcast. For example, podcasts are a great source for me. If I want to learn about industry, I go to the best founder and then listen to a 2-hour podcast. That's it. The insights of that is learning of it probably a decade. Which I do myself, like, for example, right? So because I'm looking at top level insights of that industry, right? So that is a format. So now there's everything available out in the open free, right? You can learn everything, exactly what you want. You can ask, only thing is you have to ask questions, and you get data so well prepared to absorb for you with all the formats to be absorbed. So I think for me, in fact, I was self-taught. I never listened to teachers, school, college, IIT, never ever. So in fact, I used to be in the last bench. Never listen to my teachers and just pretend that I'm listening. Probably sometimes I'm completely self-taught. I go home, read crazy, study crazy, go 2-3 layers deep, because when you listen, you can't think 2-3 layers deep. So you need to learn at your own pace. So self-learning is a heavy, it's a superpower.
And what exactly do you intend to do with Skyroot? What are the crazy things that you're doing in the next 5 years?
See, our mission statement is very clear. We want to open space for all. I mean, space is so close, 10-15 minutes away. Why are we not going to space? It's like space is not open for all. And so many space technologies open. Is every farmer in the country using an app where they can find pests in their farm, or help them irrigate, or do something? No, this is so expensive. So this thing, are the remote areas getting 100 Mbps, 1 Tbps connection to their home? So space is going to transform lives. And then the only way to expand human species is space. You have to be a spacefaring civilization. You have to have human consciousness beyond Earth. You have 5 mass extinction events. There is no other way for human life to survive, beyond certain time, without being a spacefaring civilization. So opening space for all, opening space for humanity is our mission statement. Then we're going to build the spaceships of the future and then make space open for all. It becomes so regular, so common. But space, so today we feel that space is, we think geocentric. We should not think geocentric. So whole space is our economy. So there are asteroids with they say quadrillion amounts of resources. You have innumerable amount of gold, platinum, everything. The universe is vast. So India, so the whole resources available in countries in Earth is not sufficient to sustain trillions of human beings. For example, in the future, you want to expand, you want to scale human beings. We think of scaling businesses. You want to scale civilization. How can you scale civilization? Space is the only way, right? So opening space for all is our goal. We'll do step by step. It's not going to be an easy journey, but it's going to be an exciting journey.
That's amazing, man. It's so fascinating to know that you did not mention a single number while you spoke about the dream, which is quite fascinating. And all we have to say is that we are vouching for you. And just like today, people say that, I saw Elon building SpaceX 20 years ago. Maybe we'll have the privilege to say that we saw Pawan building Skyroot 20 years ago.
Let's see.
Thank you so much, Pawan. It was a pleasure.
Thanks, Ganesh. Thank you.
So you've got an actual brain.
Yes. That's what you imagine when you see a human brain, but this is a code brain.
Is my brain like this?
Your brain is bigger than this. It's about 1.5 kilograms. If I gave you a rat brain, okay? So now that's a rat brain.
What can this preserved brain tell you about a living brain which is inside?
Okay, so you can cut this into sections.
Oh, you just cut it. Amrita Vaidya, one of India's leading neuroscientists, has spent decades studying the most complex organ in the human body, the brain. If you've ever wondered why your mind works the way it does, then this conversation will completely change the way you understand yourself. If somebody is watching this and they want to find out that what kind of winner they can be,
Go for the most sustainable. And the most sustainable is when you fall in love with doing something. That is the single most sustainable way of the long-term likelihood that you will achieve something.
can you tell me like a framework or a question or an exercise so that we can find out which process will work for us?
I would first say find out what you thoroughly have enjoyed doing. You find out whether you're willing to do the work. That's the sustainability. And 3, I think you have to ask that if you didn't get the outcome that you wanted, would the process have given you enough joy? That's the hardest question to answer, but that's the question that's worth answering.
Why are some people are so good with their memory and they remember everything versus some individuals are not?
The brain is much more plastic and much more open to change in a younger nervous system. So your first 25 years of your life, that's a window in which there's much more plasticity than in the second 25 and the last 25. It's downhill after that first 25. So when I say plasticity, it means the ability of your brain to change in response to environment, to be able to adapt better to the world.
The word which is now I'm going to say is very loosely used these days. It's called anxiety. So explain me simply, like, what is anxiety?
Anxiety is when there is no obvious threat. You can't see a threat, nobody else can see a threat. But your body is responding like there is an immediate threat. Which means what? My palms will sweat, my mouth will dry, my heart rate goes up. It's literally as bad as a heart attack.
If you open up, let's say, a billionaire's brain, Elon Musk, and you open up a brain of a 25-year-old feeling stuck, will their brains be identical or different? आगे बढ़ने से पहले इस चैनल को सब्सक्राइब कर लीजिए ताकि हम आपके लिए इसी तरह से और इंसाइटफुल और बेहतर पॉडकास्ट बनाते रहें। एंड इस पूरे शो का ऑडियो एक्सपीरियंस स्पॉटिफाई पे अवेलेबल है जहाँ पे आप हमें फॉलो कर सकते हैं। एंजॉय द शो। So you've got an actual brain.
Yes. These are your gloves.
Okay.
And that's my set. And we'll wear them because we have to wear them because these brains have paraformaldehyde in them. And so for safety reasons, we have to have our gloves on.
What do they have again?
Paraformaldehyde. That's what keeps the brain tissue fixed.
Okay.
Okay. So shall we take this particular brain out and take a look?
So if I touch it from my bare hands, what will happen?
Probably not a great idea because you might have a situation in which you might get some rash.
Okay.
Because there's paraformaldehyde in it. But I can give you some now in your hand. Now I can give you the brain. This is a goat brain. And it does in many ways resemble our brain, as you can clearly see. It has a lot of these folds, right? Because most of this tissue is folded now. So that's the gyri and sulci of the brain. That's what you imagine when you see a human brain. But this is a goat brain.
But is it like, is my brain like this?
Your brain is bigger than this. It's about 1.5 kilograms. This is clearly not 1.5 kilograms. This must be about 200.
But does it feel the same?
It feels the same if it is fixed. The human brain would feel the same if it was fixed.
Okay.
And so if you were looking at a fixed human brain, it would be larger. It would be about this much. And this is much smaller. But many of the structures are shared between the goat brain and our brain.
Tell me one major difference between our brain and goat brain and one similarity.
Okay. One big difference is if it was a human brain, the cortex, which is this part, would be much bigger. You wouldn't be able to see the cerebellum because the cortex would have expanded and flowed over the cerebellum, tucking the cerebellum underneath. So this would not be visible in a human brain as easily because this has become so large. In evolution, this has grown so big that it has flowed over it on either sides and this has got tucked in.
Okay.
Okay. The other big thing is, you remember we stand on 2 feet, right? So the bipedal. So this, imagine if this was a goat, this is its head and it has 4 legs. This has also moved like this. So you would see the human brain This would be tucked underneath. This would be much bigger and flowing on either side. The spinal cord going down like this, the spinal cord coming out.
Oh, so this is like...
This is the beginnings of the spinal cord. From here would come out the long spinal cord with nerves coming out on either sides that control the limbs, the rest of the body. That's one obvious difference. Obviously, the size is a big obvious difference.
But where does, let's say, the part which, let's say, in humans, because we are more desirous, so where the desire and ambition and all of that plays out in the human brain versus an animal brain?
So goats have the ambition of also finding effective grass to eat.
Okay.
They have that ambition. We don't consider it the kind of ambition that we think of. But if a goat doesn't have the motivation to find grass, to find food, to drink enough water, it won't survive either. So the motivation circuits are actually fairly similar. The same things that make you want to go and eat are the same things that make you ambitious to want to land on the moon. It's the same underlying circuitry. It's just that it's doing very different things in humans from goats.
Okay.
But goats have motivation circuitry. Without motivation circuitry, the animal will not survive.
And physically, where is it, if you can point out?
There's a structure called the ventral tegmental area, which will be right underneath this. So if you go underneath that, there's a structure there called the ventral tegmental area. And then there are nerves that go all the way underneath. Here is a region called the striatum. If I opened it up, you would see it. At the base of the striatum is a structure called the nucleus accumbens. That's where motivation resides.
Can I just turn it on?
Yeah, turn it on.
So this is where... And in humans also it's similar.
It's very similar. That's there whether you are a rat, you're a mouse, you're a squirrel, you're a goat, you're a human. We all have that baseline circuitry in our brain. It's the same circuitry that makes you feel thirst and motivated to go drink water, eat food, have sex. These are all the same underlying building blocks.
Under the brain.
It's inside. It's embedded underneath here.
And what is protecting? Like what's the outside?
So this stuff right here, coming out of here would be your pituitary.
What does it mean?
Which makes all the hormones of your body. The testosterone, the estrogen, the thyroid hormone, all of those hormones that go everywhere in the rest of the body and do the job of, hormonal control and metabolism, come out from a little stalk which has now gotten chopped off. But here's the hypothalamus and the pituitary would emerge from here. You can also see it in the... You would see the same thing if I gave you a rat brain, okay? So
this is a rat brain.
That's a rat brain. Now, what is obvious to you first and foremost is this is smooth. And this is curly and wrinkled, and that is absolutely smooth.
And why is like that?
That's because the cortex is relatively less in size, and in the skull it fits. Without having to fold.
Okay.
Whereas in the goat brain, the cortex is already expanded, and for it to fit, it has to fold. So if you take out this cortex and flatten it, right? Like if you flatten it out, it would be a 1 rupee coin. If you take this out and flatten it out, it'll be like a small puri.
Okay.
If you take out a monkey brain and you do the same thing and flatten it out, it'll be a largish chapati. And if you take a human being brain and flatten it out, it'll be a pizza.
It'll be that big.
It's big. So now, but the skull hasn't commensurately expanded. We are not walking around with skulls that are this big, right? Like mega mind. We have small skulls. So now the stuff has to still fit. So to fit, it has to fold and fold and fold. And that's why you have these folds which are called gyra and sulci. And here you don't need to fold.
Because
so it's a smooth brain. It's called a lissencephalic brain, which is a smooth brain.
But here's a question. So these brains are preserved brains.
Yes.
Right?
Yes.
What's the difference between a live brain, which is probably right now in my head or in some living animal, versus a dead brain and versus a preserved brain?
So a dead brain, suppose we just took the brain out of the body, then there would be a lot more blood that would be immediately visible. The brain receives a large amount of your blood supply. So you would see blood, which you don't see here at all because the blood has been removed and cleared out. Okay. Also, it's significantly softer because when the tissue dies, the cells start dying. And as they die, they literally dissolve away. There are all these enzymes that are chewing up stuff. It will fall apart. If I give you a live brain, in a few minutes, it'll start falling apart.
Okay.
Here, this is preserved because it's had formalin. A lot of people would have seen this in school when you go into the laboratories and you see things in these long jars.
Yeah.
And you see one snake or you see some body part. It's been preserved. It's been preserved by using formalin or formaldehyde, which preserves the brain. And now this will stay like this for actually years.
Interesting. But does it change anything while you're researching or doing anything?
It does change things which we can't easily test in this. So, for example, if I want to look at RNA or DNA or look at the genes that are being switched on, I can't do it in a preserved brain. I have to do it in a live brain.
And does it shrink in size?
It does shrink a little bit because this sort of formalin, once you cross-link proteins, things become tighter. And because they become tighter, things become more tightly connected. It does shrink it a little bit. So it is a little bit smaller, but not a lot.
And now that this is preserved with all these things, what can this preserved brain tell you about a living brain which is inside my mind?
So you can cut this into sections.
Okay.
So let's put this fellow back right here. And let's take that and let me show you its younger or rather other evolutionary relative. That's the mouse. So you get a sense of how the mouse brain.
Wait, mouse and rats are different.
They're two different things. I know we all say chua and we think that the chua is just a chua.
Okay, is it a genuine thing or am I like really dumb?
You would not be the first person who's asked this question. So people are like, rat and mouse, isn't that just the same thing?
Yeah.
But you've seen a big rat.
Yeah.
You also seen these little, but they're not baby rats. They're actually mice, which is a totally different species.
Oh.
So that is a mouse brain and that is a rat brain. And so the mouse is significantly smaller. It's like about 25 grams, an adult mouse.
Okay.
And a rat, adult rat would be about 250 grams.
So the big ones, yeah.
Significantly bigger, right?
The one you see on train stations, and that's
the one you see on train stations is this. The one that's probably wandering around in your house in the corner, which is eating up the food, is more likely to be a house mouse.
Okay.
Yeah. But you can see that it's very similar. Even though these animals have very different sizes, they have very similar lifestyles. They're also, nocturnal. They like to they come out at night. There's a lot of biology that's very similar, even though they're different species. And you can study a lot by studying these animals because the rules are common many times across this, and what's here.
What are common rules?
The neurons that do all the processing in the brain, they're similar here, and in our nervous system. The way they're connected and the way they're networked is different, but a lot of the basic building blocks are very similar. It's like with a Lego box, you can make a simple thing, you can make a complicated thing, you can also make something that's very, very... So the building blocks tend to be very, very similar, but as the complexity goes up, you get different function which emerges from these networks.
So you were telling me this, that when you study these brains, what do you find out about human brains?
Yeah. So let's take a look at the microscope and then you'll see what is actually inside the brain, and you'll realize that the rules are really, really quite... So let's say I want to see how neurons function.
Okay.
We can move this microscope. Let's take our gloves off.
Or maybe we can just finish this. Is it done? Or you were going to cut?
I wanted to cut. So let me cut then maybe and show you that, and then
we can go to the microscope.
Okay. So I'm going to section...
Actually cut it.
Yeah. I'm going to take a brain here and put it into what is called a mold. Okay. So this is a mold. So I'm just slicing the brain now. I'm just going to put it in a mold like this.
Okay, so this mold is for this mouse brain.
This mold is for a rat brain. Okay. I have a mold for a mouse brain, which is right here, which is a smaller mold.
Okay.
Right? But we'll use a rat brain mold, and I'm going to cut right here. Okay.
How difficult it is or easy is it for you to cut?
This is easy. When we want to cut really thin, you need machines.
Okay.
So we cut down to like fractions of a millimeter. And when we do that, then you need machines to cut at really thin levels, right? So right now here, I'm just slicing it with, this is like a regular razor blade, right?
Okay.
That's all it is. So I'm just slicing and I'll slice. Yeah, this is proving to be tricky because this blade is not as strong as the other one.
Okay.
Okay, let me just cut with this instead. All right. Yeah. Let's just put that. All right. Let's take a look now.
What's this?
All right. So now you asked me about the motivational circuitry in the brain, right? At the base of this, sitting right here, I don't know if you can see it with this, we can try. But sitting at the base of this structure right here is something called the nucleus accumbens. Doesn't matter what the name is. We all have this tendency to make very complicated names for everything in the brain. Unnecessarily complicated. We could have made it a lot simpler, but there were so many different structures, they got called many things. There's a little region right here at the base, which is the region that produces and receives a lot of dopamine.
Okay.
And that's the part of your brain that's involved with motivation. So it's right here at the base. And
So show me, like, just point it out, where would it be?
that I will have to cut this. If we want to see it,
Because on the bigger brain, I'll be able to.
Yeah, hold on.
Oh, you just cut. Oh, you just cut it.
Hold on. All right.
I don't know how you're doing it. So, like,
So this here is the base of this is actually the basal ganglia. This whole region is the basal ganglia, and this base region is the same region that I'm showing you here. These are all the fibers that are coming, that are collecting information from all over the cortex. This region is the cortex.
Okay.
This white structure that is running down here, can you see this white line?
Yeah.
That's called the internal capsule, and it carries fibers from the brain all the way down to your spinal cord. So this single neuron that projects from here could sometimes, in the case of a human being, be 1 meter long. It's one cell, but its projections could be right from here all the way to your spinal cord. It controls your ability to sit, walk, move, etc. Right? So this region is that area. You can actually see it here as well. There, right there at the base.
This white thing.
Yeah, and the white thing running through it is the internal capsule. This is the base.
So this is responsible for motivation.
Motivation. This receives innervation from the base of the brain, which is this area.
So what is different in people who are not motivated versus people who are?
So pretty much everyone is motivated for at least baseline level rewards. Otherwise, you won't survive.
But does the brain look different of high achievers versus
not drastically so, but possibly in the neurochemical transmission, yes, because in the detail of what gives you your dopamine hit, possibly. I mean, the dopamine hit that someone who's willing to go and do the work to climb to the top of Mount Everest will likely be very different from the dopamine hit of someone who's saying, I'm a couch potato and I will eat the potato chips while watching someone climb Mount Everest. It's likely to be different, but it'll be in the minor detail, not in the large scale. So in principle, that couch potato is also capable of absolutely getting up, doing the work and achieving that. So inherently, the building blocks are there in every individual.
Got it.
Yeah.
So it's mostly the neurotransmitters which actually makes difference.
Neurotransmitters, the strength of signal between one neuron and another, the receptors that respond to the neurotransmitters, that level of detail changes based on what you do. So for example, let's say someone actually trains to go to base camp. They are training and really training every single day. That training does something to your brain.
True.
Right? There's a difference between in principle seeing it and in practice doing it. Yeah. It's like saying I want to be a concert pianist, but I will listen to a concert pianist. I'm not enough to become a concert pianist. Yeah.
It's a good example. I'll come back to that, okay? Because the pianist, I have something, a nuance for it. But so you're telling that brain of a couch potato of somebody who's not an achiever is exactly same, more or less, is same like an high achiever.
In its broad structure, 101%.
But is it like heavier? Because I heard that Einstein's brain weighs more than like a normal human being.
So Einstein's brain is thought to have had more gyri and sulci, so more folds. Now in its detail, no one sits and counts every neuron in the brain, right?
Okay.
We know that we have some X number of neurons, close to just about, in the billion range neurons. But the thing is that you're not going to sit and count every neuron and see whether one individual's brain versus another differs in the numbers. Numbers can differ though, because we know that even in rats and mice, when you put them through life experiences, especially animals that have a lot of not challenge, but stimulating environments tend to end up with more neurons in their brain. So we do know that stimulation and the quality of environment can change the number of neurons in the brain. So there is that possibility.
So the theories and like what people say that because Einstein's brain was heavier, it has nothing to do with his intelligence.
A little unlikely to have been just that. It's probably what he did with that brain and how he trained it and how he used it that made all the difference. It's not to say that there aren't inherent differences in ability. There are always some inherent differences in ability, but a lot of it is what you do with those inherent differences. And that is training. There's no question about it. You can train the brain to do a whole bunch of things that you didn't anticipate that you could do.
And is bigger brain better?
Not necessarily, because you can have a camel brain, it's pretty huge. So now, for a camel it works beautifully, but if you and I, so just bigger doesn't necessarily mean better, right? Like you can have a bigger brain. So a goat has a significantly bigger brain than a rat, but it can't do some of the things that a rat can do, and a rat cannot do some things that a goat can do. So these brains have been evolutionarily adapted to be ideally suited for that particular species.
Got it.
For a rat, it has this huge olfactory bulb. Can you see that at the front? This structure. This is what is involved in its sense of smell. And now you know that rats are super smellers and mice are super smellers. They can smell stuff that you and I can never smell. We will not even be able to detect the odor.
So will dogs have the similar thing? Will have bigger?
Absolutely. So their olfactory system is way more complicated than ours. So if I was to say that we'll give an award for the best smeller, hands down the rat will win over you and me, right? So essentially, depending on the function we are looking at, species evolved to make the function more suitable for it. So dogs, especially bloodhounds, etc., that do a great job of smelling things, they have complex olfactory systems. Ours has become rudimentary. And that's because we went bipedal. So our dependence on smell is less. Our dependence on vision is a lot more. We use sight to do a lot of our discrimination of the universe.
Interesting. And I have a very good smell. That's what I would like to think.
Yeah, but hands down between you and a rat will be hands down smell better than you.
I am only comparing with my 10 humans.
Sure.
No, fair. Okay, so you were... And there's this one word which I've heard a lot, which is called grey matter.
Yeah.
What is grey matter in this?
Okay, this was great that you just asked me. That is exactly, this is grey matter and this is white matter.
What do they do?
First of all, it's obvious that they look different in color. Right?
Grey and white.
It's kind of pinkish.
ఇప్పుడు ఒకసారి చెప్పేసావా వెళ్ళి కాల్ చేసి వాడింటికి వెళ్తున్నా ఓకే